All right, welcome young people. In this video, we're going to watch a little bit more about bonding basics, just the beginning, kind of a general understanding of why bonding occurs. So topics to understand: how do bonds form? What is the octet rule for all? What does that mean? What is ionic bonding and what is covalent bonding? We're going to be looking at all of those things. So how do elements bond? All elements bond for the same reason. They want to become stable. And stability is determined by valence electrons. And this stability is achieved because everybody wants to have a stable octet. Well, there are already elements on the periodic table that have a stable octet. Those are the noble gases. They already are stable. So everything else is trying to become stable like a noble gas. So valence electrons are the electrons in the highest or outermost energy level of an atom. Valence electrons are the only electrons generally involved in bonding. D block gets a little weird because sometimes we get some non-valence electrons in there, but D block's weird. Don't worry about that. So when valence shell is full, the atom is stable. It's less likely to react. So example, a noble gas. Krypton is a noble gas. Notice it has 8 valence electrons. It is not very likely to react at all with anything because it is a stable noble gas already. So binary compounds are compounds formed from only 2 elements. So it can be either ionic or covalent. It can also be acids, which we'll talk about a little bit. Ternary compounds are compounds formed from 3 or more elements. So anything that's got 3 or more is considered to be ternary. Again, we can have ionic and or covalent or acids or basic acids like this as well. But we'll only be looking at ternary ionics and acids. We won't be looking at naming ternary covalents because they go beyond the scope of what we need to know. You'll get a little bit more of that in biology, but we won't do that here. So which are ternary and which are binary? So let's look. NaCl. NaCl is binary, I believe. Yes, let me get a pen. There we go. NaCl is binary. CO2, binary. NO, binary. MgF, that's binary. KNO3, that's ternary. CH4, binary. PbCl, binary. H2O, binary. CuSO4, that's ternary. SF6, that's binary. Okay, so 2 elements, binary, more than 2 elements, ternary. Okay, ways elements achieve stability. So there are 2 ways. 1, they can transfer electrons. 2, they can share electrons. So an element that wants to lose electrons will lose them to an element that wants to gain electrons. So that's what we're talking transfer of electrons. We know that these elements want to either lose or gain electrons, and they will achieve that by one that wanting to lose and the one that wants to gain. They will come together and they will make sure that they lose and gain equal amounts of electrons. So in doing this, both elements achieve a stable electron configuration or an octet. So in sharing, an element that has 4 or more valence electrons, these are elements that really like electrons, except for hydrogen. Hydrogen is the only one that doesn't have 4 or more. Hydrogen only has 1 valence electron, but hydrogen is a nonmetal. Okay? Again, sharing, both elements achieve an octet. They achieve an octet or stable electron configuration. So which type of elements want to lose and gain? So losing electrons, elements with low valence numbers like to lose electrons. Gaining electrons, elements with high valence numbers tend to gain electrons. So elements on the periodic table generally have low valence numbers. Which ones are they? Yeah, metals are the ones that generally have low valence numbers. So which elements on the periodic table generally have high valence numbers? Yeah, nonmetals have high valence numbers. So that means if I'm transferring electrons, this kind of bond will form between a metal and a nonmetal because metals want to lose electrons, nonmetals want to gain electrons, and so I'm going to see metals and nonmetals come together and transfer electrons from one another. The metal losing, the nonmetal gaining. Okay, these kinds of bonds are called ionic bonds. Sharing electrons will be formed between a nonmetal and a nonmetal, so these are only nonmetal bonds. Okay, these kinds of bonds are called covalent or molecular bonds. I'm sorry, I probably should have not divided that up a little bit. Covalent or molecular. Molecular is another name for a covalent bond. Okay, so which are ionic and which are covalent or molecular? We're going to use I for ionic and C for covalent or molecular. NaCl. That's a metal and a nonmetal, so it's an ionic. Okay, CO2, carbon, oxygen, those are both nonmetals, so that is covalent. NO, oh, nonmetals again, there you go. MgF, magnesium is a metal, fluorine is a nonmetal, there you go. Okay, KNO3, K is a metal. N and O are both nonmetals, so that's got to be ionic. CH4, C is a nonmetal, H is a nonmetal, so that's not ionic, I'm sorry, covalent. PbCl, Pb is a metal, lead, and Cl is a nonmetal, so that is ionic. H2O, H is a nonmetal, O is a nonmetal, so that is covalent. CuSO4, Cu is a metal, S and O are both nonmetals, so that's ionic. SF6, sulfur and fluorine, both nonmetals, so that is covalent, okay? So that's the end of that. Hopefully you've gotten a little bit from that and you will be able to use it. Thank you.